Today, we are not just talking about large language models. We are talking about transforming those models into active production ready LLM agents. I am Sumit Kumar Das and welcome back to SKT Neuron. By the end of this video, you will understand exactly how AI agents work and have a fully functional agent that can use multiple tools to solve real problems. So, let's dive in. First, let's understand what makes an agent different from a regular chatbot. When you ask any question to any regular chatbot, it gives an answer. That's it. That is one shortcut. But what if the answer requires multiple steps? What if it needs to search the web or calculate something or check real-time data? That's where agents comes in. At its core, a LangChain agent is a system that connects a large language model like GPT-4, Llama or Gemini kind of models with a set of tools. You can think of the large language model as the brain and the tools as its hands or utilities. The large language model does not just respond, it actually reasons about what it needs to do. It looks at the user's query and thinks, do I already know the answer? Or if not, which tool do I need to use? How should I use the tool? Or what should I do with the results from that tool? This process of reasoning and acting is often called as react pattern. And it is one of the agentic architecture that becomes so powerful that instead of being confined to the training data, they can interact with the real world. I have also explained six different types of agent architecture in the video attached in the description below, and also explain React in complete detailed way to refer out. Coming back, every LangChain agent is built on three core components. First is the model, that is the brain, that is the large language models that do the reasoning part. And second is tools. Tools lets you agent actually do things like search the web, query databases, send email, or whatever you need. These are either Python functions or the API, the agents that can call. And third, most important is system prompt. This is the personality that tells the agent how to behave, what its role is, and how it should approach the problem. You can think all of them like the model is the brain, the tool are the hands, and the system prompt is a training manual. Alright, now let's jump into the code. Before that, we need to get our environment ready. And today, we'll be working with Gemini model. But if you like to explore other models, please check out the LangChain playlist, link in the description below. I have also included a detailed walkthrough of the complete LangChain development setup in that playlist. Coming back, large language models is the reasoning engine of your agent, and tools gives the agent that ability to take actions. Now let's see how we can create some tools. Tools can be simple Python functions or preferably decorated using tool decorator to fully customize names, description and schemas. An agent requires this list of these tools to operate upon. And if you provide an empty tool list, the agent will function only as a single large language model node without any tool calling capabilities. And here I have created three useful tools. But you notice some important things here. First is we have used tool decorator. This tells LangChain that hey, this is a tool the agent can use. And second most crucial is that it's docstring because the agent read this docstring to understand what the tool has the capability to do. It's like the instruction manual for the agent. And third is specified types. For example, it's string in query that tells the agent what kind of input it needs. In a real-time application, you need to connect these to actual APIs like a real search engine, a database, external services. But for learning purposes, this simulation will work. Let me run this. And now, let me print some of the metadata related with these tools. So here, using this code, you can see I am printing what is the name of the tool, what is its description, and what is the argument schema it has. I have printed for all the three tools I have created. Now bringing it all together, let's create the agent. So here if you observe, There are three things happening. One is model setup. It means here we are using the Gemini model, which is very fast and cost effective. And the most common approach is using a static model that configured once during the agent creation, where you can use model identifier string directly. For example, GPT-5, right? That is for automatic inference. But if you need complete control over the parameters like temperature, max token, or timeout, you need to pass a configured instance model like we passed here. Second is the create agent function. Here we pass our model, we pass our all the tools available and the system prompt that explain the agent role. But what exactly is the system prompt? This is like agent job description. We tell it what it can do and how it should behave. But when no system prompt is provided, the agent will infer its task from the messages directly given by the user. The agent is now ready to use. But how do you actually use it? To run the agent, you use agent.invoke function. You use agent.invoke function, passing an update to its state, typically a new user message. Let's me run it fast. Now, let test our agent with different scenarios. Okay, let me run it first. Let's see what is happening here. First, it reads the question. First, it try to understand what is the human-based question have is given. Then it decides which tool to use. Here, if you can see, it has decided to use the get current time tool. Next, it executed that particular tool and it extracted the result from that tool. And that tool has been passed to the agent which gives you the complete answer. Similarly, I have executed it for two other scenarios where in one scenario it is trying to call our calculation tool or mathematical based tool. Now let's try to hit our third test scenario where we're trying to do the web search. Let me hit it where I'm trying to ask what is the San Francisco current today's temperature, and it is giving me it's sunny and 72 degree Fahrenheit. It is giving the result based on the what we given in the domain tool domain tool call. But now, so these are all standard questions or direct question I will say. But now let me give a complex question here. So till now, whatever the use case we have said, in those, all it is using is single tool call. Now let me give a complex question where it should use multiple tools together. So here I am asking search for the AI in use and calculate how many days until the end of the year. So here if you see, first it is calling the web search to check for search for the AI news, because for that it need to do web search, and it got the update latest AI news is new GPT model released with improved reasoning. Now after that it need to calculate how many days is left till the end of the year. For that it needs to first know what is today's date. So it calls the get current time, because until unless it is not knowing what is today's date, how it will calculate how many days left till the end of the year. So here you see, it is calling multiple tool calls in a sequential way. Now, if you want to see the agent thinking in real time, we need to use streaming. Since many agents often execute many complex tasks in multiple steps, where a full invoke call can take time to get the result. So in such scenarios, we have to track our intermediate progress. That's why we'll be using our streaming method. Let's see how streaming works. Okay, now let me run this. And let's observe here how it is giving the response. See, it is giving it that this is getting calculated while the agent has not been completed yet. Now it used the calculator, get current time, it got the current time, it did the calculation, it got the final response. And here, remember one thing, I am using here stream mode is equal to values. That will help you to receive chunks that represent the full state at that point and allow you to display all the ongoing reasoning, be it tool calls or final output in real time. Now, let's level up with some advanced features. To build some customized behavior beyond the basic loop, we need something called as middleware that will help us for processing state or modifying responses or implementing custom logic. Let's see. So one of the most useful feature is handling tool errors. In such scenarios, we'll be using one decorator from the middleware that will handle the tool error exception. Okay, so here if you observe, first I have created a tool called as divide number, which will divide two numbers given by the user. Now, after that, I am creating a handle tool error function with the decorator called as wrap tool call getting imported from middleware, and that I am passing while creating the agent. So let me run it first. Now let me give a question that will give, we know that that mod question will fail, that is 2 divided by 0. Let me run it. I have provided. So here you see we are using the wrap tool called middleware decorator where we can catch exception and it will return the tool message with a custom error message to the model that will prevent a hard crash and allow the agent to potentially retry or adjust reasoning. So here if you observe, I have given the tool message here and here I am providing the my custom message that will come up here as a form of tool message. Next is dynamic model selection. It means it allows the agent to switch models at runtime based on the current state or context. Essentially, maybe for cost optimization or increasing sophistication as the conversation grows. Let me show one example to you. So here if you see, we are using the wrap model called decorator again from the same middleware that help us switching the model. I have defined two model. One is bigger model with higher cost, another is smaller model with faster response and lower cost. So that whenever my message count goes greater than 5, I will use the bigger model to get better response. But whenever my message count is less than 5, I will use the basic model or the cost effective model. So it helped me switching the model in dynamic without redefining the agent multiple times. Similarly, similar to the dynamic model, there is one more concept called as dynamic system prompt. Okay, what it will do? It will also help you to modify the system prompt based on the runtime context or agent state. Again, using the same middleware. Let me show the same thing also again. Here again, see, I am calling the dynamic prompt decorator from again middleware. So here if you see, I have defined one something called as user role in my agent. That user role, and I am passing that user role here in the form of context schema and it is going that user role here. And if the user role is export, it is changing my system prompt. I mean, I have a base prompt, which is a that will be applicable to all the users. Let me say I have a pool of users where few users are expert, they need some detailed response, but few users are very beginner, they need simple response or response in a simple way where they can understand easily. So that I have created two user roles and it's generate system prompt based on the request, based on the user request. So these all advanced features will help you build production ready agents that can handle errors, that that can switch between different models based on the complexity, or also it change the system prompt based on the requirement. So where would you actually use this? Let's see some real world application. First is customer support agent, where you can check your order status in your database, process refunds and returns, search knowledge base for answers, and you can escalate complex issues to the human as well. Second is research assistant. Search multiple sources, summarize findings, and compare data from different websites to generate the reports. Third can be your data analyst agent, where you can query database, perform calculation, generate visualization, or create automated report. Next can be your personal assistant. that can check your calendar and send emails, search the web, set reminder and schedule tasks. And you can also build a DevOps agent that can monitor server health, deploy application, check logs, and alerts on issues. The possibilities are endless. Any task that require reasoning plus action can be automated with agent. And here are some of the best practice we follow in the industry now. Like always use environmental variable for API keys. Always keep the clear tool description that agent relies on them heavily. And don't forget to implement error handling. And always test thoroughly before you move into the production. And that's it. You know now how to build AI agents with LangChain. These are some of the next steps you can follow after building this agent. And if you want, I have already explained multi-agent system in detail in the video attached in the description below. And the complete GitHub code is available in the description. If you found this helpful, smash the like button, subscribe for more such AI development content, and drop a comment telling me what kind of agent you want to build. Thanks for watching and keep learning, keep coding, and keep growing.